Hi, so my name is Munib Ahmed and I'm part of Group 5 of Computer Science Department. And my group was particularly working on a web application for the Year 2 group project of Module 2001, which is a group project for Year 2. And we were working on a web application that would allow the users to navigate safely to their destination based on the reports and crimes in the area. So we were successfully able to integrate and create our web application and able to demonstrate it. So the components that I worked on were quite several all over the application on different pages. So the most prominent ones were the first one was authentication using JSON Web Tokens, FAQs page, and report markers on the map. And then additional things like chatbot, 404, not found page, weather APIs, server connection, and styling of footers and social links and everything. So I'll just dive right into it from starting from the backend, and I'll just show that our backend is running, which is connected to port 8080. So my idea was to create backend that is quite similar to front end using JavaScript. So that would be easier for the whole group to just work through it and understand it, as it would be somewhere relevant to React.js, as our backend is in Node.js and our front end is in React.js. So Node.js is quite similar in the phase of like it's JavaScript and a bit polished, just like React.js. So the first thing I would tell about is creating a server, which I authored and created in the very first place. I'll just skim through it and show that it is right now connected and running. So we used Express.js as creating a server connection and for the server call to the SQL database, and then sending the response to front end, which is again front end using the Axios library. So we use cores for the cross-origin resource because the backend is running on port 8080 and the front end was running on port 3000 or 3001 based on the front end browser. So mostly it was 3001. So we use core to align and coincide the data transfer between requests and responses. And for the routes, what I did was I created each page, each backend route or express route as a component. So that would make it easier for everyone in part of our group to just work in their own file rather than messing up any file or just creating anything that would disrupt the whole function of the server. So that allowed me basically to create a whole bunch of files out here, and based on each file it was exported as in this context it was written and then exported, and then in the index.js I imported every file and created like a routes for it, and then it would loop through all of them using our server. So as it routes through all of them, so every file is running. As soon as the server is connected, it will give that server is running on port 8080. If not, then error handling was dealt with. And then I established the connection using the database file, which was quite easier as of Node.js. .env file is the file that contains all the information about our database, and I used MySQL pool to connect it to the database. And if the database is connected, it's going to give you the database connection, which is in this terminal written. And if it is not connected, it's going to give you that it's not initialized. And by this function, it returns this database connection, and exporting this and using it in all of my files as a function, it connects to the database. So that's how initially I created the server and we did all our files. So moving on to the next thing was the FAQs page, which I'll show you the backend first. As always, we used Express and got the connection from the database file. We used the get method, and this was the path for FAQ call. Get method would just read the FAQs in it, and after getting the connection, this was the SQL query that will show all the questions and answers and send it to the front end as part of an array. And if not, it's going to give you an error, which is internal server error, which was checked, as we will check through the postman. And if we send it, apologize. If we create a GET request and we send it, it's going to give all the questions with their answers, as every question has auto incrementing ID. So, and all of the questions are stored in our database in the FAQs table as question and answer. And then taking to the front end. Front end contains the very same thing as Axios creates the FAQs call to the backend, and response of data is then added into this use state hook as FAQs are set to that, and then FAQs are returned. Every time the page reloads, it gives it reloads the FAQs from the database. And then the other thing that was happening, and that was you can add your own question and a search bar. Now I'll go to the FAQs page in our front end to show that how it's all working. So the first thing that was added was a search bar, which loops through all of the questions inside our database and gives you an answer based on what you have written on the on change effect. It triggers on every word we type and gets all the answers from the database from it. These are all the questions listed inside our database, and if we want to add a question, and we add this, you can see that it comes in our list. In our developer tools, we'll again see it, and we will see that we have the question with ID number 30, as this is the new question, and we can check it through our database as we can reload the FAQs table, and you can see that this last question with ID number 30 is the one that came up as a new question. So one thing I forgot was showing about the search bar code. First, the backend was pretty much simple. It was a GET request of the search bar, and we get the search query from the front end, and then we trim any extra spaces or trailing. Then we get to the connection to the database, and then we find any questions that, like that phrase that's given inside our search query, and then that search term is searched, and answer is given in a part of array and sent to the front end. If not, then the error handling was quite obvious. And the search bar, as I said, I did every part as a piece of a component and then added it, so it makes it more usable and reusable if any other page or any other place we need it. So we created a search query from Axios. The search term params were set, and every search term we use the hooks, and if there was an error, we give an error. Otherwise, we set the response that's sent by backend to us into the search results, which is this, and it triggers every time we change the search term, like we add any alphabet to it. It triggers again, and then we return it with the list of for the styling, and it maps all the results, and then it places them down in a part of, like, the first one is question and then answer as a part of a list, as you can see out here. And then the next part was about the authentication, which is basically the sign up and login page. So first I will go through the sign up. In our database, we have the users table, which contains all the data of users. You can see that the email and the password is hashed for the security reasons, so nobody, even the admin, can't see it inside the database for security purposes. And these are all the columns that we have inside our database that are populated using this sign up page. So first I'll just get you to the code of backend for the sign up. So the sign up works as pretty same structure. It's a post request as we are adding inside our database a new thing, and it gets all these things from the body of the front end through the inputs. And if there is anything not available in the front end, like any part is missing, any field is missing, it's going to give the missing fields error, and it's going to be displayed inside our page at the front end. Then we check that if the email is already inside our database, which is being added again for the sign up, then it gives you an error that user already exists and with the 409 conflict. Otherwise, hashes the password to the 10 rounds with using the bcrypt library, and it hashes the password and saves it inside the database by this part, as the result is populated with these names inside these columns of our database. And if there is any error, it's going to throw an error. And then we get the inserted ID, which is the latest ID to which sign up button is clicked, and we get the ID uh, of that thing. And with that, we assign the JSON web token, which contains all of these elements from the database which are being sent right now. And we create a token of it, and then we have the secret key inside the env file, uh, which is for the security purposes. And then we create a token for it which expires in 2 days, and it gets stored inside the database for 2 days and then expires. And if there is any problem, it shows an error. Otherwise, it returns the token and stores inside our browser. And the same goes for the login page. We get a connection, we make a post request, and then we get email and password from the request body, and we get a connection to the database, and then we check the email and we check the password, and we get the password, and we use bcrypt.compare to check that the password is equal to the password that's hashed out inside our database. And if the password is correct, it's going to generate the JSON token and it gets stored inside our browser the same way. And if not, it's going to return an error message. And if there is some tampering with the token inside the database, it gives that unauthorized thing or error. So just to demonstrate that using Postman, we'll use login, and as part of body, I have this email and password inside my database stored, as this is one of the thing that I have. And this was a post request, so I'll create a post request and I'll send it, and it's going to return the token with the header authorization thing. And once it's decoded, it contains all the information of the user which is being used all throughout our web application. And this was the most part of login page that I did. It sets token. Once the button is clicked of login, it's gonna refresh the page and populate all the fields of the user data, and it's gonna console log that the login is successful. So I'll just demonstrate it now. We'll just use any new email, Alan Turing 007, and we'll use Alan Turing. We'll use Brunel University. I'll check. Yep, that's correct. Brunel University. And this is for the address 401A Brunel, and this is for the postcode UB89JH. Just to show that if we have anything missing, it's gonna give us the error. The username must be 5 characters long, so we will just add it, sign up. So it signs us up and logs us in. So now all our data is stored, and everything is stored in this very token that we have. So now we have this token, and if we want to log out, or if we remove this token, we are logged out from our web application, and we need to sign in again. So we do the very same thing. We do Alan Turing 007, and we add Brunel University. Check it, that's correct. Yes, that's correct. And we submit it, and it's gonna give us all our details populated inside our profile page. And these three, as these are in tokens, so these are fetched through the local storage, uh, which is our token. And if we again remove this, it's going to log us out, and uh, pardon, and it's going to log us out, and we will not see anything, and it will ask us to sign up again, which is what I did inside the profile page. And by any chance, if we have anything wrong, if we have wrong password, let's just say this, and it's going to give that you have wrong credentials. And if we add the correct password, it's going to log us in. So this was one of the things that I had to do, and it stores everything inside our local storage as the token is again stored. And we can console log everything that is part of this authentication part. But as the page reloads, it just removes all that data for the time being. But using this page, if we test out the sign up route, yep. So if we check the sign up page and we do sign with something new, we need 00758, and we type new thing, password gets the very same. And now if we sign up and we go to our dev tools, it's going to show that all of our data is console logged out here and the way it is being stored. And I'll just demonstrate everything by our database as everything is being populated. So the new user we created was Alan Turing 007, which is this, and we have password hashed, we have 401 Brunel, UP8, and then later on the new sign up that I did was Munib 00758, and the way it is being stored inside our database and being populated correctly. So this was the whole authentication thing. And one additional thing was with this, as if we reload it and if we log out and we go to the profile, this is what comes up as you're not signed in, and this takes you to the sign up page. This is what I did if the user is not logged in, and I had to do it going inside the profile page, which is profile page is out here somewhere. Yep, here it is. So it was pretty simple, but I used the token to fetch it, to get the token, as I created the use token and use user hooks that get the token, as these are the hooks that get us the token, as this token is stored in the local storage, and it sets the token inside the local storage. And this is the use user hook uh, that also plays a vital role in setting the token inside our browser, and sets the user as the get payload token from is got. Otherwise, it sets the user to null if the token is not available out there. So just coming back to the profile again. Once a token was fetched, this takes place. We get the server response. Otherwise, we make it, and it runs every time the token is changed or the user is changed. And the most of it is self-explanatory. So this was the only thing that I did in this part and created some styling of it. So coming up to the next was going to the home page and adding this weather API that gets the weather data, and the open weather was used to get this API. And to check this loader spinner was added to show the functionality that the weather is being loaded right now. and it was all done as a part of component as well in our front end, which is weather.js. Open weather map was used, and we used the use effect hook to get the data, and the data was gotten as part of your location by using the React as getting the position based on longitude and latitude, and then getting the data from the weather API and setting it out. The next thing was a chatbot, which I created. This was the pretty much hard-coded chatbot, which I called Sophie, and its basic uh, use or its basic thing was to allow the users to get the safety tips, to get the application guide, and to get if you found anything lost on your track, or if you found anything while using our application, you can just go to the Metropolitan website and report it to the Metropolitan Police of UK. And if you want to give us any feedback, any positive thing, any issues or anything, you can just go to email us and report us anything like that. So again, I use chatbot as part of a component, reusable component, and pretty much hard coded all of it and added functionalities to it, which was these were the options that we had. Safety tips, and with the safety tip we have online safety, personal safety, and home security. The same goes for application guide. We had various options. FAQs would take you to the frequently asked questions, as every part of it was done in here. And if you want to remove the chatbot, you can just press the cross button and it gets invisible. And every response was delayed for 5 seconds just to show that it's a sort of a humanly AI response. And part of it, we use this function basically to check the category. If the category is FAQs, it's just going to take you to the FAQs page. Want to report any item, report the lost item, it's just going to take you to the lost and found property of the Metropolitan Police website. And the same goes with every part of it. If you have suggestions, it's going to take you to mail us, and everything happens like that. We have the handle return, and these are some functions that I initially used to handle scroll and everything. And this was pretty much hard-coded chatbot. It's going to give you safety tips, let's say personal safety, and it's going to give you all the safety tips based on that. If you cross it, it's going to get away, and then it's going to start up again. And if you found anything, then it's going to give you options, and based on every option, you can go to the website. And that was pretty much of the chatbot. This was a hard-coded chatbot. And the next thing was one of the main things that I did was report markers. As you can see on the map, we have this remote marker. Every marker displays a report, and if you want to see anything, it's going to take you there. We have a road is broken, it's going to take you there. While report is loading, it's going to show you the report threat, the report state, time, and report detail, and report type, and also who made this report. So just taking you to how this was implemented. This was implemented in the home page here. So from line 520, here's how I did it. We got the token, we get the response, and from there we get the user ID, we authorize it, and the data which we get from it as part of user ID. So that's how we populate the user profile, and then from that profile thing we get the name and everything of the user. And once the token changes, the user is obviously changed, and it triggers again. All right, this was the main part from which we fetched the reports, and this was the use effect hook, which was used to get all the reports data. And by making request to this part, we were able to get the data, as you can see in the postman. If we make the get request to the localhost 8080, it's going to give us all the reports data. And like this, since the image is very long, so it's the image data is quite long, as changed to base 64 image type. But all the reports have their own properties, like this. like this, like then the above report had pretty long type data. So once we get the data from the Axios, we set it to reports, and then we get the time and everything, and we use the switch statement to change the report type. Either it's based on road faults, traffic, crime, or anything, and based on that we've set the time, that how long does it take for the report to expire. So every report has its own time. Some have 1 day, 6 months, 2 days, or probably 5 hours or 2 weeks, based on any report type. And then we check that report hasn't expired, and based on that we set report. From there, since the report marker is based on the longitude and latitude, we check that which part is it on, and then we narrow it down, and then we change it to a number, since in the database it is being stored in a part of a string, which is of longitude and latitude, right here, and it's part of a string, so we change it to a number, and we check that it doesn't have the invalid coordinates. Then if not then we do this part, whole of it. Every time it refreshes, it's going to run again, and the markers are again depending upon the report type, whatever it's on. The icons are like this, and this was most part of it. And then we created also the reports detail page, which gets the report based on the report ID, and it sets as the part of response data to the report, and then it displays all the data, and with joining it with the users table in the backend, we're able to get all information about the report, like this in here. And this is how the reports are displayed based on the longitude and latitude of the reports that is being stored inside our database for each report, and the address of it as well. So the next thing was regarding to, if you go to any other page that is not even present inside our database, it is going to take you to the 404 not found page, which shows like, says like this. It's basically about designing, and this link will take you back to the home page. If you again go to any page that's not even inside our database, it's going to take you to the home page, as the page you're looking for is not available. And the next thing which I did was creating the whole styling of this page, creating the logo of the Safe Stride, creating the login design and everything, and creating this footer that is that gives us all the basic links to the social applications of X, Facebook. I'll just show some of them. So this is the Safe Stride Facebook page that we created to promote our application. That same goes with the X page, and it takes you to the Safe Stride, Safe City, Safe Strides page. So this was a whole lot of the work that I did, and each part of it is tested and uh, working perfectly fine using Postman and using the developer tools. Everything is being stored inside our database, and everything is working perfectly fine as FAQs and users, reports. Everything is being populated perfectly fine. And uh, in our FAQs page, we had add question route as well, which basically inserts question inside the database, which is this, and I nearly forgot it. And the way it added the question inside the database was using this as a backend, as we have add question post request, and it inserts inside our database question answer section, and with the answer, which is a waiting response, and it has to be answered by the admin, but the question is inserted inside the database, and as part of the array all of the questions are retrieved. So this was mostly part of it which I did, and the components that I worked on from start to end. So here I conclude my whole recording video demo with all of the things, uh, the way I played part in it, and the way I did stylings, the way I did various components, and the way I worked as a group uh, to work through all of the pages, most part of the pages, uh, and work in a part of a group environment that does not disrupt uh, or just break down any part of someone else's code and then efficiently work on it.